Direct current motor. Direct current motor is a device that converts electrical energy to mechanical energy. It works on the principle of the interactions between the magnetic fields of a permanent magnet and the field generated around a coil conducting electricity. The attractive and repulsive forces between the magnet and the coil create rotational motion. The following diagram shows the basic structure of a direct current motor. It consists of a rectangular coil of wire mounted on an axle between the curved poles of a U-shaped permanent magnet. The two ends of the coil are soldered to each of two halves of a copper split ring. The split rings function as a commutator. The carbon brushes are pressed lightly against the commutator by means of springs. The purpose of using a split ring commutator is to enable the current in the coil to change direction each time the coil passes through the vertical position. The change in the direction of the current in the coil enables it to rotate in the same direction after it passes through the vertical position. The working of a simple direct current motor is described in the diagram shown. When current flows through the coil, the side AB of the coil experiences an upward force and the side CD, a downward force. These two forces form a couple which causes the coil to rotate clockwise until it reaches the vertical position. When the coil is at the vertical position, the carbon brushes touch the space between the two halves of the commutator, thereby cutting off the current to the coil. Because of inertia, the coil does not come to a stop, but will continue to rotate past the vertical position. When the coil rotates past the vertical position, the split rings change contact from one brush to another. This reverses the current flowing through the coil. The reverses in the current flowing through the coil also reverses the forces acting on its sides. The side AB now experiences a downward force, and the side CD an upward force. This enables the coil to continue rotating in the same clockwise direction so long as the current is switched on. The speed of rotation of a simple direct current motor can be increased by increasing the current in the coil, increasing the number of turns in the coil, and increasing the strength of the permanent magnet. Thank you for taking time to watch this.